In this video, we're going to look at writing the equation of exponential functions from their graphs. And we're going to write our exponential functions in the form of y equals a times b to the x power plus c. And we'll start here with this graph on the left-hand side. Now, c, when I'm in the format y equals a times b to the x plus c, c is the horizontal asymptote. Because exponential function should have happened at y equals 0, and if it doesn't, or have the horizontal asymptote at y equals 0, if it doesn't have the horizontal asymptote there, then that was my vertical shift. So that's one of the first things we look for. So graphically, where are you getting flat at? We're getting flat in this problem at y equals -4. So that means c is equal to -4. That is the first thing that you look for. So what we have is we have y equals a times b to the x power minus 4. From here, what you're going to do is you're going to use the coordinates. So if I have 2 points displayed for me very nicely, I'll use them. However, if I don't, I would look for lattice points on the graph. So where does the graph cross? Perfectly in the corner of one of these grid blocks. Well, each coordinate gives you an x and a y. So of course, an x and its corresponding y value. So I got 0 and -1, and I got 2 and 8. So what I'm going to do is I'm going to plug those in to my equation and see what I have afterwards. So if I have -1 in for y, that's going to give me a times b to the 0 minus 4. And then I have 8 equals a times b to the second power minus 4. And so I have these two equations here that I want to use to solve for the constants a and b. Well, we're actually very lucky in this problem because I have b being raised to the 0 power. B being raised to the 0 power makes 1, and so this equation here is going to give me -1 equals a minus 4. Which I add the 4 over, that's going to give me 3 is equal to a. So I already know what a is. A is 3. And now that I have a, it's going to require a lot less work out of us to figure out what b is, because I could go ahead and put the 3 in for the a, rewrite my second equation, so I have 8 equals 3 times b squared minus 4. And then I can go the work from there, so I'd add the 4 over, gives me 12 divided by 3, gives me 4, so I got 4 equals b squared. And then I would take the square root of both sides. So square root of 4 is 2. The square root of b squared is the absolute value of b, which means that we have two possible answers for b. We have b could be positive or -2. The exponential functions that we're going to write are all going to have positive bases. So we're going to have b is equal to +2. Now, in fact, another way we could tell is that if I had a negative base, my function wouldn't be as smooth as this because every time I had an odd numbered exponent, I would have to, my value would be negative for that base, and this graph would kind of jump all over the place. So it's going to be positive. Our equation we put those coefficients in would be y equals 3 times 2 to the x power minus 4. Now let's look into it one more time here in this next one. So as you can probably expect, this next one probably is not going to be as straightforward as the other one, but my process stays the same. Our goal is to write an exponential equation in the form y equals a times b to the x plus some c power. You find c by identifying the horizontal asymptote because that'll give you that vertical shift. We have a horizontal asymptote here at y equals 1, which means c is equal to 1. Once I get that, I now know that I have y equals a times b to the x plus 1, and we have to solve for a and b. Solve for a and b, use the coordinates, because they give you an x and a corresponding y. So I have -1 and 1/3, and I have +1 and -5. And we're going to plug those in for x and y, and we're going to see how to proceed from there. So I'm going to start with the one that's on the right-hand side. So I have -5 is equal to a times b to the 1 power plus 1. And then I do my second equation, which is 1/3 is equal to a times b to the -1 plus 1 power. Now from here, I can't really do much because I have two unknowns in the same problem. And it'd be a little messy to try to rewrite as A equals or B equals and do substitution. So what we're going to do is we're actually going to isolate the A times B part. So I need to move the positive ones to the other side, and I need to rewrite what I get after that. So I subtract the 1 over. My top equation becomes -6 equals A times B to the 1 power. I don't need to write that one, but I am for right now. Then I minus the 1 in the equation below it. 1/3 minus 1 makes -2/3. So I got -2/3 equals A times B to the -1. We have a system of equations here. The way we're going to solve this system of equations is through division, because through division, I can eliminate a variable. I can eliminate A through division because A divided by itself makes 1. And so if I divide, so I have top divided by bottom. So -6 divided by -2/3 is going to actually make +9. So I have 9 equals. The A's cancel. Then I have B to the 1 divided by B to the -1. Properties of exponents, you divide like bases, you subtract your exponents, top minus bottom, that's going to give me B squared. Now I take the square root of both sides, so the square root of 9 is equal to the square root of B squared. The square root of 9 makes 3. The square root of B squared is the absolute value of B. We're using B is equal to +3 instead of B is equal to -3. So I'm using the positive value for my base. Now that I know what B is, you need to figure out what A is. So to find A, you're going to pick the easiest looking equation to use. So I'm going to use the one where B has a positive exponent instead of a negative, and I'm going to plug in. So I'm going to say -6 equals A times, now we just got B to be 3, times 3 to the 1 power. And then we would solve. So I'd divide by 3 here, and that's going to give me -2 is equal to A. We have all of our coefficients. We know what A is, and we know what B is. So the equation of that exponential function that is graphed is y equals -2 times B, not B. We know B is 3, so -2 times 3 to the x power plus 1.